Hi ladies and gentlemen, this is Mr. Green again, and we're going on in Chapter 4, and this is so another lesson in my pre-cal lessons, and I appreciate you being here. Just letting you know, we're still moving forward in Unit 4. Make certain that you have all your zeros taken care of. Zeros in the grade book really affect the grade and really cause it to be a lot lower than it needs to be. So you want to make certain you get all the zeros taken care of as quickly as you possibly can. Okay? Last time I talked a little bit about exponents. X to the 23rd power meant 23 x's in a row being multiplied together. So when you multiply exponents, things with similar bases together, you just add the exponents together. When you're dividing things with similar bases, you just subtract the exponents. You're going to be looking at that. That's this rule, these two rules right here. Okay? That's this rule here and this rule right here. Okay, those are dealing with exponents. There's a few other rules that are presented in session 2, in the study 2, that you need to be aware of. First of all, this one. This is one that a lot of people don't know about. This one says that if you have anything raised to the 0th power, that is actually 1. That's all it is 1. Okay? So you raise anything to the 0th power, you get a 1. That's how you can work with these, and it really helps a lot. If you're multiplying, or I'm sorry, if you bring something that's to a power, something that's an exponent raised to a power, and then you raise that to another power, you actually multiply the exponents together. So m times n rather than m plus n or anything else. It's m times n. Okay? Now, if you have a negative exponent, that actually means 1 over that same thing in a positive. So it's like 1 over that m to an absolute value of that m. So if you're looking at 3 raised to the negative 4th power, you're actually looking at 1 over 3 to the 4th power. Okay? And if you're looking at something that's got parentheses around it, like AB here, that have these parentheses raised to the nth power, that's each item in there raised to that power. Even if it means having to go through there and take and multiply like we did up here. That would be an appropriate thing to do in that situation. Same thing's true when you're dividing. If you're dividing by power, both of them get that same power. Okay? Cool. Having said that, that's one of the big things that's in this lesson, is doing those type of things. So let's just look at one of them right here. If I have 28 to the 63rd power times 45 to the nth power, and that's equal to 28 to the 63rd power, how do I find n? I know you're looking at me going, my calculator doesn't go that high. I can't do that sort of stuff. I purposely picked very high numbers because it is just so ridiculous that 28 to the 63rd power, no one can do that. You're right. No one should be able to do that on their calculators. But you know what? I can find n very, very easily. Why? Because if I divide by 28 to the 63rd power, I get 28 raised to the 63 minus 63, or 28 to the 0th power, which is 1. That means 45 to the nth power needs to equal 1. If 45 to the nth power equals 1, n has to equal 0. That's how easy that type of work is done. Okay? What we're leading to are some exponential decays and exponential growth type problems. Okay? And you're going to be getting those next time. So what you need to be realizing is we're talking about n raised to the x power. And your calculator does graph these, okay? So what I want to show you is if I take the calculator and I clear it out and I say something like 5 raised to the x power, okay? And I want to graph that one out, and I hit graph, what I will get is a graph like that. Now I want you to notice it's going through the number 1 right here. It's going through 0, 1. If I try this again and say, well, what about 8 raised to the x power, and hit graph, what do I get? Well, it does something like very similar. It's a little bit inside, but it's still going through 1, 0, 1. really, Mr. Green, I'm getting an interesting concept here. What about 0.02 raised to the x power? And graph that out. What's going to happen there? Well, it's going to be a little bit insight here, okay? But it still goes up like that, and it's still going through 0, 1. Why is it going through 1? Because anything raised to the 0th power will give you 1. So whenever you see x to the 0th, anything that has a 0 in it, something raised to that 0th power, it's going to be 1. So every one of these graphs, no matter what they look like, whether they look like this one here that's going up to the right, or this one over here that's going up to the left, they're still going to go through that point, 0, 1. Okay? And this helps us a lot, because if we see a graph that looks like an exponential and it's not going through 0, 1, but it's going through 0, 43, that must mean that it's been shifted up 43 units. And if it's not going through 0, 1, but it's going through -3, that must mean it's been shifted down 4 units. Those are the types of things that you can look at to help you figure out where what graph you're looking at. Okay? So those are the types of things that go on with these exponential programs. You're going to be looking at exponential growth and exponential decay, and those are things that we're going to be looking at next time. And it'll be an interesting little concept that we're dealing with. Okay? I do appreciate the fact that you've been very good about telling me that you all are in pre-cal. It does help me a lot. It helps get me in the right location to answer your questions in a real hurry. And I appreciate that. If you have any questions, I do appreciate you sending me a K-mail. You can call or come on by Toga. I do Toga every day of the week for an hour from 3 to 4 on Monday through Thursday, and then on Fridays from 11 to 12. And I'm there to help you. If you need help, please come on by and let's talk about it. So I'll look forward to seeing you next time. Bye.